What if I told you that everything you think you know about time is fundamentally wrong? Picture this: you wake up tomorrow, and suddenly you realize that the clock on your wall, the calendar on your desk, even your heartbeat counting the seconds, none of it existed before a specific moment 13.8 billion years ago. But here's where it gets mind-bending. If time itself began with the Big Bang, what does that even mean for existence before that moment? Was there a before? And if there wasn't, how can we even use the word before to describe it? Today, we're diving deep into one of the most profound questions in all of science and philosophy. Did time exist before the Big Bang? Prepare to have your understanding of reality completely transformed. The paradox that breaks our minds. Let's start with something that should make you deeply uncomfortable. When scientists talk about the Big Bang, they often refer to time zero, the moment when time itself supposedly began. But think about that phrase for a second. How can there be a zero point in time without acknowledging that something comes before zero? It's like saying, this is the first word of language, but you needed language to even form that sentence. This isn't just wordplay. This is the central paradox that has kept physicists awake at night for decades. If time began with the Big Bang, then asking what happened before the Big Bang is like asking what's north of the North Pole. The question itself becomes meaningless because the concept of before requires time to exist. But what if that assumption is wrong? What if time didn't begin with the Big Bang, but simply changed form or entered a new phase? What if our entire understanding of temporal reality is like a fish trying to understand the ocean while never having left the deepest trenches? If this paradox is already making your brain itch with curiosity, hit that like button. We're just getting started on this mind-bending journey, and trust me, it gets way more intense from here. Einstein's revolutionary framework. To understand whether time could exist before the Big Bang, we first need to understand what time actually is according to our best current science. And for that, we need to talk about Einstein's revolutionary insight that completely changed how we think about reality itself. Before Einstein, time was like an invisible river flowing at the same rate for everyone, everywhere. Newton imagined absolute time ticking away uniformly throughout the universe, unaffected by anything happening within it. But Einstein shattered that comfortable illusion with his theory of special relativity in 1905, and then dealt the final blow with general relativity in 1915. Einstein showed us that time and space aren't separate entities but are woven together into a single fabric called spacetime. Imagine spacetime as a flexible trampoline. Massive objects like stars and planets create dips and curves in this fabric. These curves don't just affect how objects move through space, they literally affect how time flows. The stronger the gravitational field, the slower time moves relative to an outside observer. This isn't science fiction, it's measurable reality. GPS satellites have to account for the fact that time runs slightly faster in orbit than it does on Earth's surface. Without these corrections, your GPS would be off by miles within hours. But here's where it gets truly mind-bending for our question about pre-Big Bang time. If space-time is a unified fabric, and if the Big Bang created space, then it also created time. They're inseparable. You can't have one without the other in Einstein's framework. This leads to a startling conclusion. Asking about time before the Big Bang might be like asking about the temperature of the color blue. The question itself might be based on a fundamental misunderstanding of what time actually is. Pause for a moment and let that sink in. In the comments, tell me, does this idea that time and space are one fabric change how you think about existence? I'm genuinely curious about your perspective on this. The standard model's time zero. The prevailing scientific model of our universe's origin, called the Lambda CDM model or simply the Big Bang theory, paints a specific picture of how time enters our reality. According to this model, approximately 13.8 billion years ago, the universe emerged from an infinitely dense, infinitely hot point called a singularity. But here's what's crucial to understand. The Big Bang wasn't an explosion in space, it was an explosion of space itself. And with it came time. In the first fraction of a second, called the Planck epoch, lasting only 10 to the power of negative 43 seconds. The fundamental forces of nature were unified, and our current understanding of physics breaks down completely. This is where the concept of time zero comes from. It's not that there was a clock somewhere that started ticking. It's that the very framework within which ticking could occur came into existence. Before this moment, according to standard cosmology, the concepts of before and after simply didn't apply. Think of it like this. Imagine you're trying to describe the plot of a movie, but the concept of narrative sequence didn't exist yet. There would be no first scene or next scene, because the very structure that creates sequence hadn't emerged yet. That's what we're dealing with when we talk about pre-Big Bang existence. Stephen Hawking famously compared asking about what came before the Big Bang to asking what's south of the South Pole. It's not that there's nothing there, it's that the question itself doesn't make sense within the coordinate system we're using. But this raises an even deeper question. If time began with the Big Bang, what caused the Big Bang? How can there be causation without temporal sequence? How can something emerge from nothing if there's no time for emergence to occur in? Where physics meets philosophy. This is where our scientific journey crashes headfirst into profound philosophical territory. The question of time's existence before the Big Bang isn't just a physics problem, it's a fundamental question about the nature of existence itself. Consider the principle of causality, the idea that every effect has a cause. This principle seems to require time because causes must precede their effects. But if time itself had a beginning, what could have caused that beginning? We're caught in what philosophers call an infinite regress. Each cause requires a prior cause, stretching back indefinitely. Some philosophers argue that this proves the necessity of something existing outside of time. A timeless realm of pure being that could give rise to temporal existence without itself requiring a temporal cause. Others suggest that causality itself might be an illusion, a pattern we impose on reality rather than a fundamental feature of it. The ancient philosopher Augustine wrestled with this very question 16 centuries ago, asking, "What was God doing before he created the world?" His answer was revolutionary for its time. Before doesn't apply to God because God exists outside of time. God didn't create the world in time, God created time itself along with the world. Modern physics has arrived at a remarkably similar conclusion, though through equations rather than theology. The mathematical description of the Big Bang suggests that time itself is a property of our universe, not a container within which our universe exists. This intersection of cutting-edge physics and ancient philosophy is exactly why this topic is so fascinating. If you're enjoying this deep dive into the nature of reality itself, make sure to subscribe. We explore these mind-bending questions regularly, and you won't want to miss what's coming next. The quantum revolution. But Einstein's relativity isn't the only revolution in physics that affects our understanding of time. Quantum mechanics introduces its own bizarre twists to the story, and some of these quantum insights might offer alternative answers to our question about pre-Big Bang time. In quantum mechanics, the act of measurement plays a fundamental role in determining reality. Before measurement, quantum systems exist in superposition, multiple states simultaneously. The famous Schrödinger's cat thought experiment illustrates this. The cat is both alive and dead until observed. Some interpretations of quantum mechanics suggest that time itself might be quantized. Made up of discrete, indivisible units called chronons, similar to how energy comes in discrete packets called quanta. If time is quantized, then there might be a fundamental limit to how finely we can divide temporal intervals. This leads to a startling possibility. Maybe asking about time before the Big Bang is like asking about a fraction smaller than the smallest possible fraction. If time comes in indivisible units, and the Big Bang represents the first chronon, then, before, the Big Bang doesn't refer to an earlier time, it refers to a category that simply doesn't exist. But quantum mechanics offers another intriguing possibility through the concept of quantum tunneling. In the quantum world, particles can appear on the other side of energy barriers that they shouldn't classically be able to cross. They don't go over or around these barriers, they tunnel through them in a way that seems to bypass the usual rules of cause and effect. Could the universe itself have quantum tunneled into existence? Some physicists propose that our universe emerged from a quantum vacuum, not empty space, but a seething foam of virtual particles and energy fluctuations that exist even in the absence of matter and space as we know them. In this model, the Big Bang wasn't the beginning of everything, it was a phase transition, like water suddenly freezing into ice. The quantum vacuum that existed before the Big Bang wasn't nothing, it was a different kind of something, a realm where our usual concepts of space and time might not apply, but where other forms of existence could be possible. The multiverse hypothesis. Taking these quantum insights further leads us to one of the most controversial and mind-expanding ideas in modern cosmology, the multiverse hypothesis. If our universe emerged from quantum fluctuations, then other universes might be constantly emerging as well, each with their own space-time fabric. In the eternal inflation model proposed by physicists like Alan Guth and Andre Linde, our Big Bang was just one of countless Big Bangs occurring throughout an eternally inflating higher-dimensional space. In this view, time doesn't begin with our Big Bang. It's an eternal feature of the multiverse, with individual universes like ours representing local events within an ongoing temporal framework. Picture a vast ocean where bubbles are constantly forming. Each bubble represents a universe with its own space-time. From inside a bubble, it looks like time began with the bubble's formation. But from the perspective of the ocean, time is eternal, and the bubbles are just temporary patterns within an ongoing process. This resolves our paradox about pre-Big Bang time in a dramatic way. Time didn't begin with our Big Bang because our Big Bang wasn't the beginning of everything. It was just the beginning of our local region of space-time within a much vaster temporal framework. But this solution raises its own questions. If the multiverse is eternal, how did it begin? Are we just pushing the problem back one level, from our universe to the multiverse itself? And if the multiverse is truly eternal, does that mean it never began at all? This multiverse idea is pretty wild, right? Do you think it makes more sense that time is eternal across multiple universes? Or that it began with our Big Bang? Drop your thoughts in the comments. I love seeing how different people approach these cosmic questions. Loop quantum gravity. Time as emergent. One of the most promising attempts to reconcile quantum mechanics with general relativity is called loop quantum gravity, LQG, developed by physicists like Carlo Rovelli and Lee Smolin. This theory offers a radically different perspective on the nature of time itself, one that might completely reframe our question about pre-Big Bang existence. In LQG, space-time isn't the smooth fabric that Einstein described. Instead, it's made up of discrete loops at the smallest scales, a kind of quantum foam where space and time come in indivisible units. But here's the revolutionary part. LQG suggests that time isn't fundamental at all. Instead, time emerges from the interactions of these quantum loops. Think of it like temperature. Temperature seems like a fundamental property of objects, but it's actually a statistical measure of how fast molecules are moving. There's no such thing as the temperature of a single molecule. Temperature only makes sense when you have lots of molecules interacting. LQG suggests that time might be similar, not a fundamental feature of reality, but an emergent property that arises from quantum interactions. If time is emergent rather than fundamental, then asking about time before the Big Bang becomes like asking about the temperature before molecules existed. The question assumes that time has an independent existence, when it might actually be a byproduct of processes that create the appearance of temporal flow. This emergent view of time offers a fascinating resolution to our paradox. There might not have been time before the Big Bang in the sense we understand it, but there could have been timeless quantum processes, interactions, and relationships that don't require temporal sequence, but can give rise to temporal experience. Carlo Rovelli describes this beautifully. Time is not a river that flows, carrying us along. Time is the river itself, and we are not separate from it, we are patterns in its flow. If time is patterns in quantum interactions, then before the Big Bang, there might have been different patterns, not temporal ones, but something else entirely. The cyclic universe model. But what if we've been thinking about this all wrong? What if the Big Bang wasn't the beginning of time, but just one event in an eternal cycle? This is the central idea behind cyclic universe models, which have ancient roots but have been given new life by modern physics. In the cyclic model, our universe goes through endless phases of expansion and contraction. The Big Bang that created our current universe was preceded by a big crunch that ended a previous universe. Before that big crunch was another expansion phase, and before that, another contraction, stretching back infinitely in time. Neil Turok and Paul Steinhardt have developed sophisticated versions of this idea using modern physics. In their model, our universe is like a membrane floating in higher dimensional space. Periodically, it collides with another membrane, creating the energy release we call the Big Bang. But time flows continuously through these collisions. The Big Bang is just a violent event within ongoing temporal existence. This model elegantly solves our paradox about pre-Big Bang time. Time didn't begin with the Big Bang because the Big Bang wasn't a beginning at all. It was just a transition from one phase of an eternal cosmic cycle to another. The cyclic model also addresses some puzzles in cosmology. Why does our universe seem so finely tuned for the existence of matter and life? In a cyclic universe, there have been infinite previous cycles, each potentially producing different physical conditions. We find ourselves in a universe suitable for our existence because we couldn't exist in the unsuitable ones. But the cyclic model faces its own challenges. How can information from previous cycles be completely erased? What prevents entropy from building up over infinite cycles? And most fundamentally, how did these eternal cycles begin? Or if they never began, how can we make sense of an infinite past? We're diving deep into some seriously mind-bending territory here. If these cosmic cycles and emergent time theories are blowing your mind as much as they're blowing mine, smash that subscribe button. We're exploring the deepest mysteries of existence. And this is just the beginning. String theory's extra dimensions. String theory, despite its controversies and unproven status, offers yet another perspective on pre-Big Bang time. According to string theory, the fundamental constituents of reality aren't particles but tiny vibrating strings existing in 11 dimensions, not just the 3 spatial dimensions and 1 time dimension that we experience. These extra dimensions might have existed before our familiar 4-dimensional spacetime emerged. In some string theory models, our Big Bang represents the emergence of 4-dimensional spacetime from a higher dimensional realm that continues to exist outside our universe. Lisa Randall and other physicists have explored the idea that our universe might be a 4-dimensional brane, short for membrane, floating in higher dimensional space. The Big Bang could have occurred when our brain separated from another brain, or when it began vibrating in a new way within the higher dimensional space. In this view, time before the Big Bang isn't the same kind of time we experience. It's a more fundamental temporal dimension within which our familiar time is embedded. It's like asking about the ocean when you've only ever known the waves on its surface. The waves have their own rhythm and movement, but they exist within a much larger and more complex system. This multidimensional perspective offers a tantalizing possibility. Maybe our question about time before the Big Bang is like asking about the color of music. We're trying to apply concepts from our four-dimensional experience to a reality that operates according to completely different rules. Brian Greene describes this beautifully. The universe we see might be like a shadow cast by a higher dimensional reality, real, but not the whole story. If our time is just a shadow of higher dimensional temporal processes, then asking about pre-Big Bang time becomes a question about the light source casting the shadow. The information paradox. Recent developments in physics have introduced another layer of complexity to our question through the concept of information conservation. According to quantum mechanics, information can never be truly destroyed, it can only be rearranged or hidden. This principle creates what's known as the information paradox when applied to the Big Bang. If our universe emerged from a singularity where all information was compressed into an infinitely dense point, what happened to the information that might have existed before that compression? Leonard Susskind and other physicists suggest that information from any pre-Big Bang state must have been encoded somehow in the structure of our universe. This is similar to how a hologram contains three-dimensional information in a two-dimensional surface. The information about what existed before the Big Bang might be encoded in the cosmic microwave background radiation, the distribution of galaxies, or the fundamental constants of physics. If this is true, then time before the Big Bang might have left traces that we can potentially decode. The early universe might be like a cosmic fossil, preserving information about pre-Big Bang processes in a form we're only beginning to understand. This connects to the holographic principle, which suggests that all the information in a volume of space can be encoded on its boundary. Applied to the universe as a whole, this principle implies that information about the interior of spacetime, including potentially pre-Big Bang information, might be encoded on the universe's boundary wherever and whatever that might be. Studying the cosmic microwave background, the afterglow of the Big Bang, researchers have found patterns that might contain information about pre-Big Bang physics. These patterns are like echoes of processes that occurred before our familiar spacetime existed, potentially offering our first glimpse into pre-Big Bang temporal processes. The idea that information about pre-Big Bang time might be encoded in the structure of our universe is absolutely fascinating. What do you think? Are we living inside a cosmic hologram that contains the secrets of what came before? Let me know your thoughts below. Consciousness and time perception. But there's another dimension to our question that we haven't explored yet: the role of consciousness in creating temporal experience. What if time isn't just a physical phenomenon, but also a psychological one? What if the question, did time exist before the Big Bang, is partly a question about the nature of awareness itself? Consider this: you experience time as a flowing stream of moments, but physics suggests that past, present, and future all exist equally in the block universe of relativity theory. Your sense of temporal flow might be created by the way consciousness processes information rather than being a fundamental feature of reality. If consciousness plays a role in creating temporal experience, then time before the Big Bang becomes a question about whether any form of awareness could have existed in pre-Big Bang conditions. This isn't necessarily biological consciousness. It could be some more fundamental form of information processing or proto-awareness built into the fabric of reality itself. Philosophers like David Chalmers and physicists like Max Tegmark have suggested that consciousness might be a fundamental feature of reality, not just an emergent property of complex brains. If consciousness is fundamental, then some form of awareness might have been present even in pre-Big Bang states, experiencing whatever form of time or proto-time existed then. This perspective suggests that our question about pre-Big Bang time might be unanswerable not because time didn't exist then, but because we can't access the form of consciousness that would have experienced it. It's like trying to remember what you dreamed before you were born. The question assumes a continuity of awareness that might not exist across the boundary of the Big Bang. Roger Penrose has proposed that consciousness involves quantum processes in the brain that connect to fundamental features of space-time geometry. If he's right, then consciousness and time might be more deeply connected than we realize, making the question of pre-Big Bang time partly a question about pre-Big Bang awareness. Quantum cosmology and the Wheeler-DeWitt equation. One of the most profound attempts to understand time at cosmic scales comes from quantum cosmology, particularly the Wheeler-DeWitt equation, sometimes called the equation for the wave function of the universe. This equation attempts to describe the quantum state of the entire universe, including its temporal properties. The Wheeler-DeWitt equation has a startling feature: it doesn't contain time as a parameter. It describes the universe in a timeless way, suggesting that time emerges from quantum correlations between different parts of the universe rather than being fundamental. John Wheeler, one of the equation's creators, described this as the universe observing itself into existence. The act of different parts of the universe correlating with each other creates the appearance of temporal flow, but the underlying reality described by the equation is timeless. This has profound implications for our question about pre-Big Bang time. If the Wheeler-DeWitt equation is correct, then asking about time before the Big Bang is like asking about wetness before water existed. Time isn't something that could exist independently, it's a property that emerges when the universe reaches sufficient complexity to contain correlating subsystems. But the Wheeler-DeWitt equation also suggests something even more mind-bending. The universe might exist in a superposition of all possible histories simultaneously. The Big Bang that we experience might be just one branch of a quantum superposition that includes all possible ways the universe could have evolved. In this view, there isn't a single answer to whether time existed before the Big Bang because there isn't a single Big Bang. Instead, there's a quantum superposition of all possible Big Bangs, some of which might have been preceded by time and others of which might represent absolute beginnings. This quantum perspective suggests that our question about pre-Big Bang time might be fundamentally unanswerable, not because we lack information, but because the question assumes a definiteness that doesn't exist in quantum reality. Digital physics and computational time. A completely different approach to understanding time comes from digital physics, the idea that reality might be computational at its deepest level. If the universe is essentially a vast computer program running on some kind of cosmic hardware, then time becomes the execution sequence of this program. Ed Fredkin, Konrad Zuse, and more recently Stephen Wolfram have explored the idea that space-time emerges from discrete computational processes. In this view, time isn't continuous but comes in discrete steps like the clock cycles of a computer processor. If reality is computational, then asking about time before the Big Bang becomes a question about what was running on the cosmic computer before it began executing the program we call our universe. Maybe it was running a different program, or maybe it was in some kind of standby mode, or maybe it was executing initialization routines preparing to run our universe. This computational perspective offers some intriguing possibilities. Computer programs can be paused, saved, and restored. Could cosmic computation work the same way? Could the Big Bang represent not the beginning of time, but the moment when a paused cosmic program resumed execution? Wolfram's recent work on computational irreducibility suggests that some computational processes can't be shortened or predicted, they can only be run step by step. If our universe is such a process, then understanding what happened before the Big Bang might require actually running the computational processes that preceded it, which could be impossible if those processes took longer than the age of our universe to execute. This raises a fascinating paradox. If reality is computational, and if pre-Big Bang processes were computationally irreducible, then understanding pre-Big Bang time might require more computational resources than our universe contains. We might be fundamentally limited in our ability to answer our question not by lack of data, but by lack of computational power. The idea that we might be living inside a cosmic computer program is pretty wild, isn't it? If these computational theories of reality fascinate you as much as they fascinate me, make sure you're subscribed. We explore these cutting-edge ideas about the nature of reality regularly. The anthropic principle and observer selection. There's another angle to consider in our exploration of pre-Big Bang time: the anthropic principle and the role of observers in determining what we can know about cosmic history. The anthropic principle suggests that we should take into account the fact that we exist as observers when trying to understand the properties of the universe. The strong version of the anthropic principle argues that the universe must have properties that allow observers to exist, because otherwise there would be no one to observe it. This seemingly circular reasoning actually has profound implications for questions about cosmic origins. If observers are necessary to give meaning to physical properties like time, then asking about time before there could be any observers might be meaningless. This doesn't mean time didn't exist before observers evolved. Biological observers appeared very recently in cosmic history. But it might mean that time before any form of information processing or observation was possible is fundamentally unknowable. Brandon Carter and other cosmologists have used anthropic reasoning to constrain theories about cosmic origins. For example, if the universe goes through endless cycles, we would expect to find ourselves in a typical cycle, not in an early or late one. The fact that we appear to be in a relatively young universe might argue against certain cyclic models. Applied to pre-Big Bang time, the anthropic principle suggests that we can only observe universes where pre-Big Bang conditions were compatible with the eventual emergence of observers. This creates a selection effect. We can never observe pre-Big Bang conditions that would have prevented our existence, even if such conditions are common in the multiverse. This observer selection effect might explain why the question of pre-Big Bang time seems so paradoxical to us. We evolved in a universe where time appears to have begun with the Big Bang, so that's the only type of temporal structure we can directly experience. Other forms of time or temporal structure might exist in the multiverse, but we can't observe them because we couldn't have evolved in universes with those properties. Experimental approaches and future detection. Despite the seemingly abstract nature of these questions, physicists are developing experimental approaches that might eventually shed light on pre-Big Bang physics. These experiments won't travel back in time, but they might detect signatures of pre-Big Bang processes encoded in the structure of our universe. Gravitational wave detectors like LIGO and the planned space-based detector LISA might be able to detect gravitational waves from the very early universe. These primordial gravitational waves could carry information about conditions before the Big Bang became opaque to light, potentially revealing signatures of pre-Big Bang physics. The cosmic microwave background (CMB) radiation has already provided clues about the very early universe. Future CMB observations with higher precision might reveal subtle patterns that could distinguish between different models of cosmic origins. For example, certain patterns might indicate whether our Big Bang was preceded by a big crunch, emerged from quantum tunneling, or represented an absolute beginning. Particle accelerators like the Large Hadron Collider are probing energy scales that existed shortly after the Big Bang. While we can't directly recreate Big Bang conditions, we can study the fundamental physics that would have operated during those earliest moments. Understanding these physical processes might reveal whether they require pre-existing time or could operate in timeless conditions. The James Webb Space Telescope and other next-generation observatories are allowing us to see further back in cosmic history than ever before. By studying the most distant galaxies, we're seeing the universe as it existed when it was very young. These observations might reveal signatures of the transition from whatever existed before the Big Bang to the expanding universe we observe. Quantum experiments are also relevant to our question. Tests of quantum mechanics in extreme conditions might reveal whether time is truly fundamental or emerges from more basic quantum processes. If time is emergent, then understanding the emergence process might shed light on what existed before time as we know it began. It's incredible to think that we might actually be able to detect evidence of pre-Big Bang physics through experiments and observations. Which of these experimental approaches do you think is most likely to provide answers? Share your predictions in the comments. The limits of knowledge and language. As we near the end of our exploration, it's important to acknowledge the profound limits we face in addressing questions about pre-Big Bang time. Some of these limits are practical. We lack the technology or theoretical framework to fully investigate these questions. But others might be fundamental limits built into the nature of reality itself. Ludwig Wittgenstein famously said, "Whereof one cannot speak, thereof one must be silent." This might apply to pre-Big Bang time. If time is truly a property of our universe rather than a framework within which our universe exists, then asking about pre-Big Bang time might be like asking about the sound of the color purple, not just difficult to answer, but meaningless as a question. Our language and concepts evolved to deal with objects and processes within space-time. Terms like before cause exist and begin all assume temporal relationships. When we try to apply these concepts to the origin of time itself, we might be stretching language beyond its meaningful limits. This doesn't mean we should stop asking these questions. Some of the greatest advances in physics have come from pushing against the limits of language and conceptual thinking. Einstein's insights about relativity required developing new mathematical languages that could express relationships that ordinary language couldn't capture. But it does suggest that answers to questions about pre-Big Bang time might require fundamentally new forms of understanding, new languages, new mathematics, new ways of thinking about existence and causation that we can barely imagine from our current perspective. The medieval philosopher Moses Maimonides faced a similar challenge when trying to describe the attributes of God. He concluded that divine attributes couldn't be expressed in positive terms. We could only say what God is not, never what God is. Perhaps pre-Big Bang time is similar. We might only be able to define it negatively, by what it's not rather than what it is. Multiple perspectives, multiple answers. Throughout this exploration, we've encountered multiple theories and perspectives, each offering different answers to our question about pre-Big Bang time. Rather than being a weakness, this multiplicity might be the most honest approach to such a fundamental question. From the standard Big Bang model, time began with our universe, so there was no before. From multiverse theories, our Big Bang was an event within ongoing time in a larger multiverse. From cyclic models, time is eternal, and our Big Bang was just one phase in an endless cycle. From quantum cosmology, time emerges from quantum correlations and might not be fundamental. From loop quantum gravity, time is an emergent property of discrete quantum processes. From digital physics, time is the execution sequence of cosmic computation. From string theory, time might be one aspect of higher-dimensional temporal processes. Each of these perspectives captures something important about the nature of time and existence, but none might be complete on its own. The question of pre-Big Bang time might require synthesizing insights from all these approaches, or it might require entirely new frameworks we haven't yet imagined. This multiplicity of perspectives reflects something profound about the nature of ultimate questions. Unlike questions about specific phenomena within the universe, questions about the universe as a whole push us to the very limits of what can be known or understood. At these limits, different theoretical frameworks might be equally valid ways of organizing our understanding, even if they give different answers. The physicist Niels Bohr said, "The opposite of a correct statement is a false statement. But the opposite of a profound truth may well be another profound truth." This might apply to theories about pre-Big Bang time. Multiple contradictory theories might each capture profound aspects of a reality too complex for any single theoretical framework. The fact that there are multiple valid perspectives on this question is part of what makes it so fascinating. If you're enjoying this exploration of the deepest questions about reality, make sure you're subscribed. We regularly dive into these fundamental mysteries of existence. Implications for human understanding. Our exploration of pre-Big Bang time reveals something profound about the human condition and our relationship to ultimate questions. We are beings who evolved within space-time, using cognitive capabilities shaped by evolutionary pressures within our particular cosmic environment. Yet we're capable of asking questions that push beyond the boundaries of that environment. This is both humbling and extraordinary. It's humbling because it reveals the potential limits of human understanding. We might be like bacteria trying to understand the internet, equipped with cognitive tools that are simply inadequate for the task. The universe might contain forms of existence, modes of being, and types of temporal relationships that are as far beyond our understanding as quantum mechanics is beyond the understanding of a bacterium. But it's also extraordinary because it shows the remarkable reach of human consciousness. Despite our cosmic insignificance and evolutionary limitations, we're capable of formulating questions about the nature of time itself, developing mathematical frameworks that describe reality at scales and in conditions completely alien to our direct experience, and pushing toward understanding of the most fundamental features of existence. The question of pre-Big Bang time might be unanswerable not because the answer doesn't exist, but because we lack the conceptual framework to understand the answer. It's like asking a two-dimensional being to understand three-dimensional rotation. The limitation isn't in the mathematical reality, but in the dimensional framework available to the observer. This suggests that future progress on questions about pre-Big Bang time might require not just new theories or better observations, but new forms of consciousness-enhanced cognitive capabilities that could think in ways that are currently impossible for unaugmented human minds. The development of artificial intelligence and brain-computer interfaces might eventually provide these enhanced capabilities. Future AI systems might be able to work with forms of mathematics and conceptual frameworks that are too complex for biological human brains, potentially opening new pathways to understanding temporal reality. The personal dimension. But there's also a deeply personal dimension to our question about pre-Big Bang time. These aren't just abstract theoretical questions, they touch on fundamental human concerns about existence, meaning, and our place in the cosmic order. If time began with the Big Bang, it suggests that existence itself had a definite beginning. A first moment that emerged from non-existence. This resonates with creation mythologies and religious traditions that describe reality emerging from primordial void or divine action. For many people, this supports intuitions about the specialness of existence, the idea that reality itself is contingent and remarkable rather than inevitable. But if time is eternal, whether through multiverse theories, cyclic models, or other frameworks, it suggests that existence is more like a basic feature of reality rather than a special occurrence within it. This perspective can be either comforting or vertiginous, depending on your philosophical inclinations. The question also touches on personal identity and consciousness. If time isn't fundamental but emergent, what does that mean for your sense of personal continuity through time? If the universe goes through cycles, could some version of you have existed in previous cycles? If we're living in a quantum superposition of all possible histories, are there other versions of you experiencing different versions of this moment? These questions don't have clear answers, but engaging with them can fundamentally change how you experience your own existence. When you really grapple with the possibility that time itself might be emergent or cyclical or multidimensional, It can shift your entire relationship to mortality, meaning, and the significance of present moments. The wonder of not knowing. Perhaps the most profound aspect of our exploration is what it reveals about the nature of mystery itself. In our age of rapid scientific advancement, we sometimes forget that the deepest questions might not have answers, at least not answers that can be expressed in our current conceptual frameworks. The question, "Did time exist before the Big Bang?" might belong to a category of questions that are permanently beyond human understanding. Not because we lack the right instruments or theories, but because the question pushes against the fundamental limits of what can be meaningfully asked or answered by beings like us. This isn't a failure of science or human reason, it's a recognition of the profound mystery that underlies existence. The fact that we can ask questions that might be unanswerable is itself remarkable. It suggests that consciousness has evolved to reach beyond its own limitations, to point toward depths of reality that it can't fully fathom. The ancient Greek philosophers had a concept called apophatic knowledge, knowledge through negation, understanding through recognition of what cannot be understood. This might be the appropriate stance toward questions about pre-Big Bang time. We can map the boundaries of our understanding, recognize where our concepts break down, and maintain a sense of wonder about what lies beyond those boundaries. This wonder isn't ignorance, it's informed appreciation of mystery. It's the recognition that reality is stranger and more complex than our minds can fully grasp, combined with gratitude for the portion of it that we can understand. Carl Sagan captured this beautifully. "Somewhere, something incredible is waiting to be known." But he might have added, "And somewhere, something incredible is waiting to remain unknowable, at least to minds like ours." This sense of wonder about the unknowable is something I find deeply moving. How does it feel to contemplate questions that might be fundamentally unanswerable? Does it make you feel small and insignificant, or amazed that you can even ask such questions? I'd love to hear your perspective in the comments. Practical implications for how we live. You might wonder what practical difference it makes whether time existed before the Big Bang. These seem like abstract questions with no bearing on daily life. But I'd argue that engaging seriously with these questions can profoundly affect how we understand ourselves and how we choose to live. If time began with the Big Bang, it suggests that the present moment has a unique ontological status. It's part of the fundamental structure of reality, not just a subjective experience of flowing time. This can enhance the significance of present moment awareness and mindfulness practices. Every moment becomes part of the basic fabric of existence rather than just a fleeting experience. If time is cyclical, it raises questions about eternal recurrence and the ultimate significance of our choices. Would you live differently if you knew that this exact moment might repeat infinitely throughout cosmic cycles? Friedrich Nietzsche used this as a thought experiment for evaluating the quality of one's life. If you had to live it exactly the same way infinitely many times, would you be satisfied with your choices? If time is emergent from more fundamental processes, it suggests that our experience of temporal flow might be more malleable than we assume. Meditation traditions have long claimed that deep states of consciousness can alter the experience of time. If time is emergent rather than fundamental, these traditions might be accessing more basic levels of reality where temporal experience is different. If we're living in a quantum superposition of all possible histories, it might affect how we think about decision-making and moral responsibility. Are you responsible for choices made by other versions of yourself in other branches of the quantum multiverse? How do you make decisions when every possible choice might be actualized somewhere in the quantum landscape? These aren't just philosophical games, they're questions that can genuinely affect how you relate to your own existence, your relationships, your goals, and your understanding of what makes life meaningful. The role of imagination and creativity. Our exploration of pre-Big Bang time also highlights the crucial role of imagination and creativity in pushing the boundaries of human understanding. Every theory we've discussed required someone to imagine possibilities that seemed impossible, to think thoughts that had never been thought before. Einstein's insights about the relativity of time required imagining what it would be like to travel at the speed of light, a purely imaginative exercise that led to revolutionary physics. Quantum mechanics emerged from physicists willing to accept mathematical descriptions of reality that seemed to violate common sense and everyday experience. The multiverse theories, cyclic models, and ideas about emergent time all required leaps of imagination that went far beyond available evidence. These aren't failures of scientific rigor, they're examples of how creative thinking opens new possibilities for understanding reality. This suggests that future progress on questions about pre-Big Bang time might come not just from better mathematics or more sophisticated experiments, but from new forms of creative imagination. Perhaps we need artists and poets working alongside physicists and mathematicians to develop new ways of thinking about temporal existence. Science fiction has already played this role to some extent. Stories about time travel, parallel universes, and alternate realities have prepared our minds to accept possibilities that would have seemed absurd to previous generations. Maybe we need new genres of imaginative exploration specifically focused on pretemporal and transtemporal realities. The question of pre-Big Bang time might ultimately be answered not by proving one theory correct, but by developing new forms of imagination that can encompass possibilities we currently can't even conceive. The answer might require expanding human consciousness in ways that are as significant as the development of language, mathematics, or scientific thinking itself. Integration and synthesis. As we approach the end of our exploration, it's worth trying to integrate the various perspectives we've encountered into some kind of coherent understanding, not a final answer, but a framework for thinking about pre-Big Bang time that honors the complexity of the question. Perhaps the most honest conclusion is that the question itself reveals the limitations of our current conceptual frameworks. Every theory we've discussed captures something important, but none provides a complete answer. This might indicate that pre-Big Bang time is a topic that requires conceptual tools we don't yet possess. The standard Big Bang model's conclusion that time began with the universe might be correct within the framework of general relativity, while multiverse theories might be correct within the framework of quantum mechanics, while cyclic models might be correct within the framework of certain string theories. Rather than contradicting each other, these theories might be describing different aspects of a more complex reality. This suggests an approach to understanding pre-Big Bang time that's more like jazz improvisation than classical music performance. Instead of trying to play the one correct melody, we might need to learn to improvise with multiple theoretical frameworks, moving fluidly between different ways of understanding temporal reality depending on what questions we're asking and what level of reality we're investigating. The physicist David Bohm suggested that reality might be fundamentally undivided wholeness, that we can only understand through multiple, partial perspectives. Applied to time, this suggests that temporal reality might be a unified phenomenon that we can only approach through various theoretical frameworks, each of which reveals certain aspects while concealing others. This doesn't mean that all theories are equally valid or that anything goes. But it does suggest that ultimate questions about the nature of time might require a kind of intellectual humility, a willingness to hold multiple perspectives simultaneously while remaining open to possibilities we can't currently imagine. This synthesis of multiple perspectives is challenging but incredibly rewarding. If you're finding value in this kind of deep exploration of fundamental questions, I'd be grateful if you'd like this video and subscribe. It helps me know that there's an audience for these in-depth investigations of reality's deepest mysteries. Future directions and emerging theories. Even as we acknowledge the current limits of our understanding, new developments in physics and mathematics continue to open fresh perspectives on questions about pre-Big Bang time. Some of the most promising directions for future research combine insights from multiple fields in ways that might transcend the limitations of individual theories. Quantum gravity theories continue to evolve, potentially offering new insights into how time behaves under the extreme conditions that would have existed at or before the Big Bang. The recent development of causal set theory suggests that spacetime might be fundamentally discrete at the smallest scales, which could affect how we understand temporal continuity across the Big Bang boundary. Advances in cosmological simulation are allowing researchers to model universe formation with unprecedented detail. While these simulations can't directly show us what existed before the Big Bang, they might reveal signatures in the early universe that could distinguish between different pre-Big Bang scenarios. The field of quantum information theory is providing new tools for understanding how information is preserved and transmitted across extreme physical transitions. If information about pre-Big Bang states is encoded in our universe's structure, these tools might eventually allow us to decode it. Research into the foundations of quantum mechanics continues to reveal new aspects of how quantum systems behave, particularly regarding the role of observation and measurement in determining reality. These insights might be relevant to understanding how temporal experience emerges from more fundamental quantum processes. The development of quantum computers might provide new ways to simulate the quantum processes that operated during the very early universe. While we can't build classical computers powerful enough to simulate quantum systems at cosmic scales, quantum computers might eventually be able to directly model the quantum processes relevant to universe formation. Advances in neuroscience and consciousness research might also be relevant. If time is partially a product of how consciousness processes information, then understanding consciousness at a deeper level might reveal new aspects of temporal reality that pure physics can't access. The deepest questions about existence. Our exploration of pre-Big Bang time ultimately leads us to confront the deepest questions about existence itself. Why is there something rather than nothing? Why does reality have the structure it has rather than some other structure? Why do the laws of physics take the forms they do? The question of pre-Big Bang time is intimately connected to these ultimate questions. If time began with the Big Bang, we're led to ask what could have caused that beginning. If time is eternal, we're led to ask why eternal processes take the forms they do rather than other possible forms. These questions push us toward what philosophers call the principle of sufficient reason. The idea that everything that exists must have an explanation for why it exists rather than not existing. But when applied to ultimate questions about the nature of reality itself, this principle leads to either infinite regress, each explanation requires another explanation, or circular reasoning, explanations that ultimately depend on what they're supposed to explain. Some philosophers and physicists have suggested that the deepest features of reality, including time itself, might be brute facts that don't admit of further explanation. They simply are what they are, without deeper reasons. This might seem unsatisfying, but it could reflect genuine limits to what can be explained or understood. Others have suggested that the structure of reality might be self-explaining in some way, that the laws of physics, the nature of time, and the properties of existence might be logically necessary rather than contingent. This would mean that reality has the structure it has because no other structure is ultimately possible. But perhaps the most profound possibility is that existence itself is creative and open-ended in ways that transcend our concepts of explanation and understanding. Maybe reality is more like an ongoing creative process than a fixed structure, and questions about its ultimate nature are more like asking about the meaning of an unfinished poem than asking about the solution to a mathematical equation. The transformation of perspective. Engaging deeply with questions about pre-Big Bang time doesn't just expand our knowledge. It can fundamentally transform our perspective on existence. When you really grapple with the possibility that time itself might be emergent, cyclical, or multidimensional, it changes how you experience your own temporal existence. Many people report that contemplating these questions leads to a kind of cosmic perspective, a shift from identifying primarily with their individual biography to recognizing themselves as temporary patterns in the vast creative process of the universe. This isn't nihilistic. It doesn't make individual life meaningless. Instead, it can make every moment feel more precious because it's recognized as part of something infinitely larger and more mysterious. The realization that time itself might not be fundamental can also affect how we relate to mortality and change. If temporal flow is emergent rather than fundamental, then death might not be the absolute end it appears to be within our normal temporal perspective. This doesn't necessarily imply personal survival after death, but it does suggest that our relationship to mortality might be more complex than it appears from within ordinary temporal experience. Contemplating pre-Big Bang time can also cultivate intellectual humility and wonder. Recognizing the profound limits of human understanding in the face of ultimate questions can be liberating. It can free us from the anxiety of needing to understand everything and allow us to appreciate the mystery and beauty of existence without needing to solve all its puzzles. This kind of wonder has practical benefits for mental health and life satisfaction. People who regularly contemplate cosmic questions often report greater resilience in facing personal difficulties, enhanced appreciation for the present moment, and a more balanced perspective on the significance of everyday concerns. How has thinking about these cosmic questions affected your own perspective on life and existence? Do you find that contemplating the mystery of time and the universe changes how you experience your daily life? I'm really curious about the personal impact these ideas have on different people. Science, philosophy, and spirituality. Our exploration of pre-Big Bang time illustrates how the boundaries between science, philosophy, and spirituality become blurred when we approach ultimate questions. The theories we've discussed combine rigorous mathematical formalism with concepts that border on the mystical. The idea that time emerges from timeless quantum processes echoes ancient spiritual teachings about the illusory nature of temporal experience. The possibility of infinite cyclic universes resonates with Hindu and Buddhist concepts of cosmic cycles. The notion that consciousness might play a fundamental role in creating temporal reality connects to philosophical traditions that see mind as basic to the structure of existence. This doesn't mean that modern physics is simply rediscovering ancient wisdom. The mathematical precision and empirical grounding of contemporary theories represents a genuine advance over purely philosophical or spiritual speculation. But it does suggest that ultimate questions about reality require multiple forms of inquiry working together. Some of the most profound insights in physics have come from scientists who were comfortable moving between rigorous mathematical analysis and broader philosophical reflection. Einstein's insights about relativity emerged from thought experiments that were as much philosophical as scientific. Bohr's interpretation of quantum mechanics drew on philosophical traditions that emphasized the role of observation and measurement in determining reality. This suggests that future progress on questions about pre-Big Bang time might require collaboration between scientists, philosophers, and even spiritual practitioners who have developed sophisticated ways of investigating the nature of time and consciousness through contemplative methods. Rather than seeing these different approaches as competing, we might need to develop new forms of interdisciplinary inquiry that can integrate mathematical precision, philosophical rigor, and contemplative insight in addressing questions that push beyond the boundaries of any single approach. The cosmic story we tell ourselves. Ultimately, our exploration of pre-Big Bang time is part of the larger human project of understanding our place in the cosmic story. Every culture has developed narratives about cosmic origin stories that help make sense of existence and provide frameworks for understanding human significance within the larger scheme of reality. Contemporary scientific cosmology is our culture's version of this universal human need to understand cosmic origins. But unlike mythological accounts, scientific cosmology must remain open to revision based on new evidence and theoretical developments. This creates both opportunities and challenges. The opportunity is that our cosmic story can become increasingly accurate and comprehensive as our understanding develops. We're not locked into fixed narratives but can continually refine our understanding based on new discoveries and insights. The challenge is that scientific cosmology can seem cold and impersonal compared to traditional mythological narratives. Questions about pre-Big Bang time push us toward acknowledgments of ignorance and mystery rather than providing clear, comforting answers about cosmic purpose and human meaning. But perhaps this openness to mystery is itself a form of wisdom. The willingness to say, "We don't know," in the face of ultimate questions might be more honest and ultimately more liberating than premature closure through dogmatic answers. The question of pre-Big Bang time invites us to participate in an ongoing cosmic story rather than simply accepting a completed narrative. We become co-creators of human understanding rather than passive recipients of received wisdom. This participatory relationship to cosmic questions might be more authentic to the nature of reality itself if reality is indeed creative and open-ended rather than fixed and predetermined. Practical exercises for cosmic perspective. Before we conclude, let me suggest some practical ways you can engage more deeply with these questions about pre-Big Bang time and their implications for your own experience of existence. First, try what I call temporal meditation. Set aside time to really contemplate your own relationship to time. Notice how you experience the present moment, how memory creates the sense of past, and how anticipation creates the sense of future. Then try to imagine your experience from the perspective of different theories about time as emergent from quantum processes, as cyclical, as part of higher dimensional temporal structures. Second, practice cosmic perspective shifts. When you're dealing with daily stresses or concerns, occasionally step back and contemplate your situation from the perspective of cosmic time scales. How do your current worries look from the perspective of billions of years? This isn't meant to minimize legitimate concerns, but to provide a broader context that can offer relief from excessive anxiety about temporary problems. Third, engage in mystery appreciation. Instead of being frustrated by the limits of human understanding, try cultivating genuine appreciation for the profound mysteries that surround existence. The fact that we can ask questions about pre-Big Bang time, even if we can't answer them definitively, is itself remarkable and worthy of wonder. Fourth, explore conceptual flexibility. Practice holding multiple contradictory ideas about time simultaneously without needing to resolve them immediately. Can you think about time as both fundamental and emergent? As both linear and cyclical? This mental flexibility is valuable not just for understanding cosmic questions but for navigating complexity in all areas of life. Finally, connect these abstract questions to concrete experiences. How does contemplating the nature of time affect how you experience music, which unfolds in time? How does it affect your appreciation of aging, growth, and change in yourself and others? How does it affect your approach to planning for the future while remaining present to current experience? These practical exercises can really deepen your engagement with these cosmic questions. If you try any of them, I'd love to hear about your experience in the comments. And if this kind of practical application of cosmic thinking interests you, make sure you're subscribed. We explore these connections between ultimate questions and daily life regularly. The never-ending question. As we reach the end of our exploration, it's important to recognize that we haven't really ended anything. The question, did time exist before the Big Bang? Remains as mysterious as when we started. But hopefully, our journey has expanded your appreciation for the depth and complexity of this mystery. We've seen how this seemingly simple question connects to the deepest issues in physics, philosophy, and human existence. We've explored theories ranging from the scientifically established to the highly speculative. We've considered perspectives from quantum mechanics, relativity theory, cosmology, consciousness studies, and contemplative traditions. But perhaps most importantly, we've practiced a way of engaging with ultimate questions that honors both intellectual rigor and existential wonder. This approach, combining scientific seriousness with philosophical openness and spiritual appreciation, might be our best strategy for approaching questions that push against the limits of human understanding. The question of pre-Big Bang time will likely continue to evolve as our understanding develops. New theories will emerge, new experiments will be performed, new ways of thinking about temporal reality will be developed. Each generation will approach these questions with new tools and perspectives. But the fundamental mystery is likely to persist because it touches on the deepest features of reality itself. And that persistence of mystery isn't a failure, it's a sign that we're asking genuinely ultimate questions rather than merely technical ones. The question, "Did time exist before the Big Bang?" is really asking, what is the nature of existence itself? How did reality come to be structured the way it is? What is our relationship as conscious beings to the cosmic processes that brought us into existence? These questions don't have final answers, but engaging with them can transform our understanding of what it means to exist. Final reflections and future wonder. So where does this leave us? We began with a question about pre-Big Bang time, and we end with a deeper appreciation for the mystery of temporal existence itself. This isn't a failure to answer the question. It's a recognition that some questions are more valuable for the journey they take us on than for any final destination they might reach. The exploration of pre-Big Bang time has led us through the fundamental principles of physics, the deepest problems in philosophy, and the most profound aspects of human consciousness. We've seen how seemingly abstract theoretical questions connect to the most intimate aspects of personal existence. We've also seen how the boundaries of human knowledge are not fixed barriers but expanding horizons. What seems impossible to understand today might become routine knowledge tomorrow. But even as our understanding expands, new mysteries emerge at the expanding edges of knowledge. This suggests an attitude toward ultimate questions that combines humility with boldness, humility about the limits of current understanding, but boldness in pursuing questions that push against those limits. The question of pre-Big Bang time embodies this combination perfectly. As you continue to contemplate these questions, remember that you're participating in one of humanity's greatest ongoing projects, the attempt to understand reality at its deepest levels. Every person who seriously engages with these questions contributes to the collective human effort to make sense of existence. The universe somehow evolved conscious beings capable of asking questions about their own cosmic origins. This might be one of the most remarkable facts about reality, that matter and energy arranged themselves in such a way that they became capable of wondering about their own deepest nature. Whether time existed before the Big Bang, we don't know. But we know that we exist now, in this moment, with the capacity to ask that question. And that capacity itself might be as profound a mystery as the question it enables us to ask. We've covered an incredible amount of ground together in this exploration. What aspect of our journey through the mystery of pre-Big Bang time has affected you most deeply? What questions has it raised for you that we didn't address? And what do you think are some questions more valuable for the wondering they inspire than for any answers they might eventually receive? I read every comment and genuinely appreciate your thoughts on these profound questions. Your perspectives help me understand how these ideas land with different people and often inspire directions for future explorations. If this deep dive into one of existence's greatest mysteries has been valuable for you, I'd be incredibly grateful if you'd share it with someone else who loves pondering the deepest questions about reality. These conversations become richer when more voices join them. And remember, the question of whether time existed before the Big Bang isn't just an abstract scientific puzzle. It's an invitation to wonder about the nature of your own existence within the vast creative process we call the universe. That wonder is available to you in every moment, no matter what future discoveries might reveal about the cosmic past. Until next time, keep wondering, keep questioning, and keep appreciating the profound mystery of being conscious beings in a cosmos that somehow brought itself into existence, or perhaps was never without existence at all. The mystery continues.